Hello everyone, and welcome back to Introduction to Artificial Intelligence. In this lesson, we're going to look into milestones in AI development. So let's go ahead and get started. The development of artificial intelligence has been marked by several key milestones that have significantly advanced the field. This section outlines these pivotal moments, tracing the evolution of AI from its theoretical origins to its current state. The formal inception of artificial intelligence as a scientific discipline occurred in the mid-20th century, marked by two significant events that laid the foundation for the field's development. The first is the 1950s, the Turing Test, proposed by Alan Turing in a 1950 paper titled Computing Machinery and Intelligence. The Turing Test became a seminal concept in AI. Turing proposed a test to determine the machine's ability to exhibit intelligent behavior that was indistinguishable from that of a human. In the Turing test, a human evaluator interacts with an unforeseen interlocutor, which could be either a human or a machine, and attempts to determine which it is solely based on the responses. If the machine is able to convince the evaluator that it's human, it's said to have passed the test. The Turing test set an early benchmark for machine intelligence and sparked debate about the nature of intelligence and the potential for machines to replicate human cognitive abilities. It remains a touchstone in discussions about AI, even as the field has evolved beyond Turing's initial vision. The next event is the 1956 Dartmouth Conference. The Dartmouth Conference, held at Dartmouth College, is widely considered the official birth of AI as a scientific discipline. Organized by John McCarthy, Marvin Minsky, and Nathaniel Rochester, and Claude Shannon, the conference brought together leading scientists and mathematicians to discuss the potential of machines to simulate aspects of human intelligence. It was at this conference that John McCarthy coined the term artificial intelligence, defining it as the science and engineering of making intelligent machines. The conference participants outlined the initial goals of AI research, including the development of machines that could use language from abstractions and concepts, solve problems reserved for humans, and improve themselves. The Dartmouth Conference set the stage for AI research in the decades that followed, establishing AI as a distinct field of study and inspiring a generation of researchers to explore the possibilities of intelligent machines. The development of AI in the 1960s and 70s saw significant milestones and theoretical breakthroughs that played a crucial role in shaping the field. The first, in the 1960s, were expert systems. The 1960s marked the emergence of expert systems, one of the earliest applications of AI. Expert systems were designed to emulate the decision-making abilities of a human expert in specific domains such as medicine, engineering, or finance. One of the first and most notable expert systems was Dendral, developed at Stanford University in the mid-1960s. Dendral was a pioneering program in the field of chemical information designed to analyze chemical mass spectrometry data and infer the possible molecular structures of organic compounds. This system utilized a rule-based approach where knowledge and rules about a particular domain were encoded into the system. By applying these rules to new data, expert systems could make recommendations or decisions, simulating the reasoning process of human experts. The next advance was in the 1970s in neural networks. In 1974, Paul Werbos conceptualized backpropagation algorithm, a fundamental mechanism for training neural networks. Backpropagation is a method used to calculate the gradient of a loss function with respect to the weights of the network, allowing for efficient optimization during training. Although Werbos' work laid the foundation for training multi-layer neural networks, the significance of backpropagation was not fully recognized until the 1980s. It was then that researchers began to appreciate its power, enabling neural networks to learn complex patterns and relationships in data. The development of backpropagation represented major theoretical advance in AI and contributed to the resurgence of neural networks in the 1980s, ultimately establishing the modern era of deep learning. The development of AI has not been a steady ascent and has experienced periods of both heightened enthusiasm and significant setbacks. One such period, known as the AI winter, occurred in the 1980s and led to a pivotal shift in the field. In the 1980s, the first AI winter, the early 1980s witnessed a downturn in the AI field, commonly referred to as the AI winter. This period was characterized by reduced funding, waning interest, and a general skepticism about the potential of AI. The AI winter was largely a result of inflated expectations from earlier decades that did not materialize, coupled with technical limitations of the time. The challenges faced by AI during this period included limitations of rule-based expert systems, which struggled handling complex or ambiguous data, and the inability of early neural networks to scale efficiently. The reduced funding and interest during the AI winter led to a reevaluation of approaches in AI research and a dampening of the over-optimistic predictions that had previously characterized the field. In the late 1980s represented the rise of machine learning. Towards the late 1980s, a significant shift occurred in AI with a growing focus on probabilistic and statistical methods. This shift was marked by the development and adoption of machine learning algorithms, which offered a new paradigm for building AI systems. Notable developments during this period included the advancement of decision tree algorithms, which provided a simple yet effective method for classification and regression tasks, and the exploration of reinforcement learning, where agents learn to make decisions by interacting with their environment. The rise of machine learning rejuvenated the AI field, laying the groundwork for more robust and adaptable AI systems. This shift represented a move away from hard-coded knowledge and rules towards models that could learn from data and improve their performance over time. In the late 1990s and early 2000s marked a significant turning point in AI with resurgence of neural networks and the emergence of deep learning, leading to groundbreaking advancements in the field. In 1997, a major milestone was achieved when IBM's Deep Blue, a computer chess program, defeated Garry Kasparov, the reigning world chess champion at the time, in a highly publicized match. This event is significant as it showcased the advancement of strategic capabilities of AI systems. Deep Blue's victory was a result of a combination of brute force computing power and sophisticated algorithms for evaluating and selecting chess moves. The system was capable of evaluating millions of positions per second using a combination of advanced search algorithms and domain-specific heuristics. The success of Deep Blue demonstrated the potential of AI in complex problem-solving and strategic thinking, sparking renewed interest and investment in AI research. A pivotal moment in the resurgence of neural networks occurred in 2006 when Geoffrey Hinton and his colleagues introduced the concept of deep learning. The term deep learning was coined to emphasize the use of multiple layers in neural networks, which allow for modeling of complex patterns and relationships in data. Hinton and his team demonstrated that deep neural networks, when trained with sufficient data and computation power, could achieve remarkable performance in tasks such as image and speech recognition. This was a departure from earlier neural networks, which were typically shallow and limited in their capabilities. The introduction of deep learning led to a series of groundbreaking advancements in AI, including significant improvements in computer vision, natural language processing, and other areas that had previously been challenging for traditional machine learning methods. Deep learning has since become a cornerstone of modern AI, driving the development of highly capable AI systems and applications across various industries and domains. The 2010s marked a period of significant advancement in AI with breakthroughs in key areas like natural language processing and computer vision, as well as the integration of AI into various aspects of everyday life. The 2010s witnessed remarkable progress in NLP and computer vision, two areas where deep learning has had a profound impact. These advancements have been demonstrated through technologies such as Google's BERT, which is the bidirectional encoder representation from transformers, in NLP, and significant strides in image recognition algorithms. In NLP, models like BERT achieve new levels of performance in understanding and generating human language, greatly improving the capabilities of machines in tasks such as language translation, text summarization, and question answering. These models leverage deep learning to process and interpret language with a level of sophistication that was previously unattainable. In computer vision, advancements in deep learning led to more accurate and efficient image recognition systems. These systems are capable of identifying and classifying objects in images and videos with high precision, enabling applications ranging from facial recognition to medical image analysis. The 2010 onward saw the integration of AI into everyday life and became increasingly prominent in the 2010s. Virtual assistants like Apple's Siri, Amazon's Alexa, and Google Assistant brought AI into homes, providing users with voice-activated assistance for a range of tasks and queries. Advancements in autonomous vehicles represent another significant area where AI has made inroads into daily life. Developments in self-driving car technology powered by AI algorithms for perception, decision-making, and navigation showcase the potential for AI to transform transportation. AI's integration extends beyond these examples, impacting sectors such as healthcare, finance, retail, and entertainment. AI-driven applications and services have now become more common, demonstrating the practical utility and societal impact of AI in various forms. In summary, the journey of artificial intelligence is characterized by a series of groundbreaking advancements, periods of skepticism, and remarkable achievements. From its inception in the mid-20th century, AI has evolved significantly with key developments in areas like deep learning and natural language processing. Initially rooted in academic and theoretical concepts, AI has transcended its origins to become an integral part of the modern world, influencing various industries and aspects of daily life. The milestones of AI history reflect an evolving understanding of its potential and capabilities. The evolution underscores the dynamic and ever-processing nature of AI as a field. As AI continues to advance, it consistently pushes the boundaries of what machines are capable of, demonstrating its transformative impact on technology and society. Well, that's all for this lesson. Thank you so much, and I'll see you in the next lesson. Bye-bye.